Hello and welcome to 12.3 Notes. Today's lesson is on finding the surface area of pyramids and cones. And remember, just like in 12.2 Notes, surface area is defined as, well, I think the best way to think about it is the minimum amount of wrapping paper it takes to completely wrap up, in this case, pyramids or cones. Okay? So before we get started, I just wanted to go over a couple of definitions, if I may. And so please copy down this pyramid. And we have here the slant height. Okay? That is the slant height of the pyramid. And the slant height is, say if this was, well, say if you were in the Luxor Hotel. If anybody has ever been to the Luxor Hotel in Las Vegas, that is a real pyramid. It's a pyramidal shaped building that's made, whose lateral faces are entirely made out of glass. Okay, all of the triangles are made out of glass. And they have a window cleaner. And the window cleaner starts at the top, and he or she has a cable, and they go down and they clean all the windows of all the rooms. And so if this person started at the top and went down the lateral or side face of the Luxor building, that would be the slant height. Okay, it's not the height of the pyramid or the building itself. It is the slant height. It's the height of just one face. It's the height of just one two-dimensional face. It's the height of the triangle. Okay, and then we have the height of the building itself. That would be if you went inside of the pyramid and you were standing at the bottom of the pyramid and you put your head straight up and you try to look straight up to the very tippy top. That's the height of the three-dimensional pyramid. You're actually inside of the pyramid. So here the height of the pyramid is when you're actually inside of the three-dimensional figure, and slant height is when you're outside. Okay? Alright, so those are the definitions that you'll need to know. And so now we can work on this problem. Find the surface area, SA, of this regular pentagonal pyramid. So the bottom or the base of this pyramid is a pentagonal, and it all meets at a point, therefore it's a pyramid. So we have a pentagonal pyramid. What is the surface area? What is the minimum amount of wrapping paper you would need to completely wrap up this pentagonal pyramid? Well, it would equal this surface area of this gold base plus this triangle here, right? The one kind of closest to us, this one here, and then add it up with the surface area of that triangle and the surface area of this triangle that's in the back and the surface area of this triangle that's also in the back, and then this triangle here. Okay, so it's 1, 2, 3, 4, 5 triangles plus the area of the pentagonal base will give me my total surface area, right? So the height of this pyramid is 4.8, and that's 5.5, and the side length is 8. Okay, so let's work on this problem. Okay, so the area of the pentagon, this is a chapter 11 type problem, right? So the formula is 1/2 ASN, where A is the apothem, S is the side length, and N is the number of sides. We're just working now on the area of the pentagon, or the area of this gold base. Okay, it's just a two-dimensional base, and remember we studied areas of two-dimensional figures in chapter 11. So we're in kind of doing some chapter 11 work, right? So the area is equal to 1/2 times the apothem, which is 5.5, and the side length is 8, and the number of sides, well, it's a pentagonal pyramid, so there's 5, right? Pentagon, penta means 5, so that's where you get the 5 from. And then multiplying these numbers out, you get 110. So the area of this pentagonal base is 110 square meters. Okay? So the area of the pentagon, again, is 110 square meters, and you don't have to copy down this figure if you've already written it down. I've just copied it down for your convenience. And again, remember, you're in total control of this presentation, so you can always fast forward, rewind, pause, whatever you'd like to do. You're in total control. But I'm going to move on here. So now we have to find the area of the rest of the figure, which is comprised of 5 triangles. So what is the area of one triangle? Well, the area of one triangle, remember, the formula is 1/2 base times height. So we have 1/2, the base is 8, that's given, that's nice and easy. But what about the height? And when I mean height, I really mean slant height, right? The height on the side, the outside part of this building or this three-dimensional figure. Okay, so to figure that out, what we need to do is, and yeah, remember this is slant height is what I'm looking for, which would be that kind of bluish purple color. I'm looking for the slant height. Okay, so what is the slant height of this three-dimensional figure, this blue figure? That's not explicitly given to us, okay? And we need that because the formula for the area of a triangle is 1/2 base times height. So, and it's not given to us, right? This h or height is not given to us. So how are we going to find that? Well, let's take this kind of pink colored line and this line segment, and that forms a triangle, right, within the pyramid. Okay, again, these 3 line segments form a triangle, and as you can see, a right triangle. So I've taken this triangle and I've kind of copied it down and exploded it down there. Okay, and this is 4.8. That's where you get the 4.8 from, and this is 5.5. That's where I get the 5.5 from. And what about the slant height? That would be this kind of purple, blue, lavender kind of color. We don't know what that is. That's S for slant height. But again, we have a right triangle, and we're trying to find the hypotenuse, right? So we can use the Pythagorean theorem. Side squared is equal to 4.8 squared plus 5.5 squared. And so that comes out to be 53.29, and so the slant height is 7.3. All right, so I've got my slant height of 7.3. I can take that number and I can substitute it in here for my height. So remember, I want you to memorize that slant height is 7.3. I'm going to move on to the next frame. So remember, I'm going to take the 7.3 and I'm going to substitute it in for the height. But I'm going to move on to the next frame. So we have area equals 1/2 8 times height. But remember, the height, again, was 7.3. So that's where you get the 7.3 from. And then that's 29.2. So the area of one triangle, of just say, for example, that triangle, is 29.2 square meters. But there are 5 triangles. So 29.2 times 5 is 146 square meters. So that would be the sum of the areas of the 5 triangles. And so you total up the areas. The 5 triangles plus the pentagonal base is 146 plus 110. And so you get 256 square meters. So the total surface area of this pentagonal pyramid is 256 square meters. In other words, you would need a minimum of 256 square meters of wrapping paper to completely wrap up this three-dimensional figure. Okay? Okay, so our next and last problem is to find the surface area of a cone. So please write this prompt down. Find the surface area of the right cone shown. Okay? And these are the dimensions of the cone. Okay, it has a height of 20 yards, and it has a radius of 15 yards, and we don't know what the slant height is. Okay, L in this case stands for slant height. And we want to find the surface area of this whole cone. What is the minimum amount of wrapping paper it takes to wrap up, this cone? Okay. So here's the answer. we have surface area is equal to pi r squared. Pi r squared, again, should ring a bell. That's the surface area of this circle. Okay? And then we have pi rl. Pi rl, interesting. Okay, that is new material. Remember, we're not asking you to memorize different formulas in Chapter 12. In Chapter 12, the way the textbook teaches it is they have you memorize a different formula for each different figure. That's not very efficient, and there's a lot of memorization that occurs. So we're actually doing you guys a favor here by having you just add up different surface areas. But in this case, we've never come across the surface area of a cone, of the lateral side of a cone. So this is new material that you will be responsible for. You have to memorize this. It's pi rl. So if you have, for example, a waffle cone, okay, many of you have probably eaten a waffle cone. The conical part that you generally hold, the waffle cone itself, that surface area is pi rl. You take pi, multiplied by the radius, and then by the slant height, and you get the surface area of just like the cone part itself, the waffle cone part itself, the part that you generally hold when you eat a waffle cone. Okay, so that's our formula. And then filling in values, we get the radius is 15, and then we have, so that's where the 15 comes from, right? Because the radius is 15. And then again, radius is 15, but we don't know the slant height. Okay? So the way we're going to figure that out is we have this triangle, right? And it is a right triangle, so I'm going to blow it up and move it down here. And the height is 20, and right there, that's where you get your 15 from. And we need to find the slant height, which is the hypotenuse of this triangle. Well, you can use the Pythagorean theorem, of course. L squared is equal to 20 squared plus 15 squared. But why don't we do this one based on triples? Okay, so 15 is equal to 3 times 5, and 20 is equal to 4 times 5. And then, we have a 3, 4, 5 triangle, right? That's a primitive that we have asked you to memorize, a 3, 4, 5 right triangle. But it's not a primitive, it's not a 3, 4, 5. Every quantity is multiplied by 5. So we have 3 times 5, which is 15, 4 times 5, which is 20. So this must be a 5 times 5. In other words, the slant height is 25. Okay, now that I know my slant height, I could substitute that in there. Okay, and I get 15 squared is 225. And then again, the slant height is 25. And then 15 times 25 is 375. And then add those two up, and you get 600 pi square yards. So the complete surface area of this right cone is 600 pi square yards. Multiplying 600 by pi, you get 1,885 square yards. Okay? So that's the end of today's lecture. If you have any questions or concerns, please feel free to contact me at your convenience, and it would be my pleasure to help you. Okay? Bye-bye.